Hello, my dear viewers and subscribers. Welcome back to the TruVerAck channel. If you're new here, hit that subscribe button and turn on notifications so you don't miss out on our deep dives into AI and machine learning. Today's talk is about Dina algorithms or architecture. I've put the link to the original article in the description below. Check it out for the full technical details. From general knowledge, we remember some machine learning approaches: supervised, unsupervised, and reinforcement learning. The environment of our Dina algorithm is reinforcement learning. So what kind of problem does the Dina algorithm try to solve? Think about a situation where you have to make decisions under uncertainty. For instance, you're going to invest in the stock market, looking for promising companies. You've analyzed a lot of data and reports, but you don't know the future. You can't predict what will happen during the world's geopolitical changes and global events. Before diving deeper, let's define our actors. Agent, an entity that makes decisions and interacts with the environment. Environment, the external system the agent interacts with. State situation, a representation of the current situation in the environment. Reward, immediate feedback the agent gets after taking an action in a particular situation. Next up, showing you an example. Often said to be the most difficult maze in the world, the Villa Pisani Labyrinth is also among the most photogenic and the most historic, having been constructed in 1720. Even Napoleon tried to complete it after he seized the estate in 1807. Rumor has it that Napoleon was stumped by the winding paths and their many perplexing dead ends, and he gave up. Hitler and Mussolini also had their first official meeting at the villa, but had other things on their minds besides mazes. Visitors who successfully navigate the labyrinth are rewarded with lovely views from an 18th century turret. We're going to use this maze to find a solution through storytelling. Let's jump into it. The Lost Explorer and the Enchanted Labyrinth, a tale of learning and planning. In the sun-drenched gardens of Villa Pisani in Stra, Italy, there stood a legendary hedge maze, a sprawling labyrinth of 9 concentric rings made from towering boxwood hedges. Its paths twisted like serpents, filled with dead ends that could trap the unwary for hours. At the center rose a spiral tower said to hold a hidden treasure, a golden key that unlocked wisdom. Many had entered, but few emerged victorious without losing their way multiple times. Our story follows 2 explorers, both eager to conquer the maze but using different minds to guide them. The first was Quinn, a bold but impulsive adventurer who relied solely on trial and error, what scholars of the mind call plain Q learning. The second was Dina, a clever strategist who not only learned from her steps but built a mental map to plan ahead, embodying the Dyna-Q approach. Let's follow their journeys through the labyrinth, one after the other. Quinn's trial, the path of pure persistence, plain Q learning. Quinn arrived at the maze's entrance on a crisp autumn morning, the hedges casting long shadows like whispering guardians. With no map or prior knowledge, he plunged in, his only guide a simple rule: try actions, remember what works, and adjust based on rewards. In his mind, he kept a mental ledger of Q values. Estimates of how good each choice, turn left, right, or straight, was in each spot state of the maze. At first, all values were 0, he'd learned by doing. His first attempt was chaotic. Starting at the outer ring, Quinn chose paths randomly to explore. He turned left into a promising alley, only to hit a dead end after 10 minutes. No reward, just a lesson. That action in that spot gets a slight downgrade in his ledger. Backtracking, he tried right and wandered deeper, but another wrong turn led to a loop, circling the same hedge for what felt like eternity. Hours passed, the sun climbed high. Finally, by sheer luck, after 50 twists and turns, he stumbled into the center tower. A +1 reward, the golden key gleamed and his ledger updated. Every action along that haphazard path got a boost, especially the last ones near the goal. Energized, Quinn reset at the start for another go, an episode in learning terms. This time, his updated Q values nudged him toward better choices near the end, but the early parts were still guesswork. He explored randomly again, finding a shorter path by accident but wasting time on old mistakes. Dead ends frustrated him. He learned only from real steps, no shortcuts in his mind. After 20 episodes, days of wandering, the maze began to make sense. His policy improved: pick the action with the highest Q value most times, explore occasionally. By the 25th try, Quinn zipped through in under 10 minutes, his ledger now a reliable guide. But oh, the bruises from all those real-world bumps. Plain Q learning worked, but it was slow, demanding countless real trials to propagate knowledge from the goal backward through the vast maze. Quinn emerged triumphant, key in hand, but exhausted. Persistence pays, he muttered, but there's got to be a smarter way. Dina's triumph, the power of imagination, Dyna-Q. Enter Dina, Quinn's wiser counterpart, who arrived the next week with a twist. She didn't just learn from reality, she built a model of the world in her head and used it to plan simulated adventures. This was Dyna-Q in action, Q learning plus a mental simulator for extra updates without extra footsteps. Like Quinn, Dina started with a blank Q ledger and random exploration. On her first trek, she noted every step meticulously. In this spot, state S, turning left action A led to that dead end, next state S, with no reward R equals 0. She stored it in her internal model, a simple table predicting outcomes for each state action pair. After hours, she too reached the center, plus 1 reward, updating her Q values just like Quinn. But here's where the magic happened. Back at the start for episode 2, Dina didn't rush in. While taking real steps, she paused mentally between them to plan. For 50 quick simulations per real move, she'd randomly pick a past state action from her model. Remember that early turn. Simulate it, predicts S, and R, then she'd update the Q value as if it were real, using the same formula. New Q equals old Q plus learning rate, R plus discount, best Q in S, old Q. It was like daydreaming victories, propagating the goal's reward backward through unvisited paths without moving a muscle. In her first episode, the model was sparse, so planning helped little. But by the second, it bloomed. Discovering a key junction near the center in reality, her simulations rippled the knowledge outward. If that leads to the tower, then earlier spots should aim there too. Dead ends in her mind taught lessons without real frustration. After just 3 episodes, Dina's Q values were polished across the entire maze. She navigated the 9 rings flawlessly, avoiding loops and dead ends she'd only visited in imagination. The concentric design, with its repetitive patterns, made her model efficient. Simulations filled gaps fast. Dina claimed the golden key in record time, emerging with a smile. "Why wonder when you can wonder?" she said. Her approach integrated reacting quick choices, learning from real experiences, and planning model-based simulations, making her exponentially faster than Quinn in this complex labyrinth. The moral of the maze. In the end, both conquered Villa Pisani's twists, but Dina's Dyna-Q proved superior for worlds like this, large, deterministic, where real trials are costly. Quinn's plain Q learning is sturdy for simple tasks but plods in vast spaces. Dina's method, by building and querying a model, turns limited experiences into boundless insights, much like how humans plan vacations without booking every flight. If the maze was stochastic, random winds pushing you off path, Dyna-Q might need tweaks, but here in Italy's orderly hedges it shone. And so, the labyrinth teaches, true wisdom comes not just from doing, but from dreaming what could be. In a nutshell, Dyna-Q is an RL agent that learns from real actions via Q updates, builds a model of the environment, then plans by simulating random past experiences to accelerate Q value improvements. That's it for today's video. If you enjoyed this dive into Dina algorithms, give it a thumbs up, comment below with your thoughts. Have you tried implementing Dyna-Q? Share your experiences, and subscribe for more AI adventures. Thanks for watching, and I'll see you in the next one. Bye.